Hello, in this video I'm going to demonstrate how one runs a model. In this case the model will be a cylinder code. This is a plane strain cylinder analysis code used to predict the stresses, strains and displacements for a composite tube. And so the procedure for running the model will be explained shortly, but before I get into that I want to just remind the user what essentially goes on in the back end when I do run a model. So this slide kind of shows that process. So we're going to be running a cylinder analysis, and that is a model SMARTree with its own associated model SMARTtag. And what that model will be doing will be pulling properties within a laminate, the laminate that describes the cylinder architecture, from the material SMARTrees, which you have in your libraries. And once again, those material SMARTrees have properties. These properties are referenced by a property SMARTree, which leverages the unit SMARTree to associate the units with those properties that carry to the material that is yet then used in the model. So this is what's going on in the back end for cylinder design. In fact, this is what's going on in the back end for pretty much every model that you run in SMARTree, whether it be laminate analysis, micromechanics, or cylinder design. So let's just get to that model. So here's our SMARTree client that you're probably familiar with. And what I'm going to do is I'm going to start the software when you start it. What it does is it sifts through all your smart tags and organizes all of the data so that you can directly access the material inputs, in this case for your model. So the work tree on the right, I've already preloaded the cylinder analysis. You can find it in here under models, mechanics models, and here is a cylinder design right here. So that's this model right here. It's pretty easy find. You can also use the search functionality to find that as well. The model itself is not running, so in order to run the model, you simply go to the model tab on top and you select the appropriate model. This drop-down list is populated automatically through the association of models and templates. And so what you have here is the first one right here is the cylinder design model. And when you click that, what happens is it will execute the model, and it will give you some information on the bottom left about the state of the model. So what it's saying here is I'm using this apply composite, and it says it found those materials in my libraries. It found orthotropic materials for those layers, and so it's essentially good to go. So the model itself is usually broken up into three main sections. We have a model header or title area where it just describes the model. Maybe there's a website. There's typically an identifier. In this case, it's CYL. That means that this software knows that you're trying to run a cylinder analysis. Then you have your model inputs. For the cylinder, you need a layup for your cylinder, and this layup can be a combination of laminates, resins, metals. You can have metal liners in here. You have a wide berth of materials to choose from, and so that's your laminate. And then for the cylinder, we have the dimensions section under the model inputs. Basically, the radius, the length of the tube, the toe or tape width. We use that input if you want to apply tension to the material. It will actually predict the stresses and strains from winding tension. Autofrettage for steel tubes that undergo plastic deformation, we can define that here as well, and whether or not the tube is open or closed. In terms of the loading, we can apply internal, external pressure, an axial force, torsion, winding tension, as I mentioned, or even a temperature gradient as well. And in terms of additional temperature gradients, we can apply a process temperature. This is essentially a cooling temperature that you might have for a composite tube that goes from a process temperature for cure stress-free temperature down to room temperature, so it can predict the stresses from that. Operating temperature is the tube, obviously the temperature that the tube is exposed to in its operating environment. And this final feature here is an option where you can define whether the entire tube goes through a constant delta T during production, or if it's a tape placement tube. In that case, the surface ply undergoes a thermal gradient, and the residual stresses from this are typically different than that of a full cylinder cure. So those are the inputs described here. And then finally, you have your model outputs. So the model outputs are broken into stresses. We have global stresses, principal stresses, and we also have strains. And so what I've done is I've populated this, and typically these results are in tabular format, but there's also plots in here as well, so you can click on any one of these plots and plot your data. And you can go back up to your inputs and you can change the various attributes of your material, whether it's the radius of the tube. You can vary that quite easily, and you will see what that does to the behavior of the tube. What you're looking at here is your hoop, radial, and shear stresses. You can also change the pressure, internal pressure, for instance. You can apply an external pressure as well. So you can have multi-load cases. You can apply an axial load and see what that does as well. So you can apply a wide variety of loading conditions to the tube and see what happens. As I said, you can also plot, in your stresses, you can plot your stresses in an external window. So here's an external window. I can go back to my layup, which is shown here, and I can vary the layup. For instance, I can maybe modify what material I want to use for any ply, or I can add plies. For instance, I can add more plies in here, and it will find those properties, and then you can plot the results for that. And so that's basically how it works. So yeah, so that's an inline model simulation for a cylinder, and it follows the basic principles of all the models, where you have an input section described in green, you have results defined in blue, and the units. If you're plotting results or having units, you can also describe those here as well. They will show up in yellow. Thank you.